is finding volume with other cross sections. So cross sections are not always circular. So in the rotation problems that we did, like rotating things around the x-axis, y-axis, the line x equals 2, and so on, those all created circular cross sections. Do you guys remember doing those? Okay, so sometimes they aren't circular. So on these problems, we still use the fact that the volume is the integral of the area, right? We talked about that relationship, the area of the cross sections. But our area does not involve that pi r squared because we don't have circles. So here are a few examples of this. So this first one actually does have semicircles, but we might also have other things. Do you guys see this shape? Can you guys see what kind of cross sections this would be if I chopped it where those vertical lines are?
Rectangles.
Yeah, they're rectangles. Does that make sense? So a rectangle will create that kind of like ridge, those two ridges along the top. So we can have lots of strange looking, oh, I don't have any more pictures of those. So we can have lots of strange looking shapes with that. Okay, so it says find the volume of the solid whose base is the region bounded by the lines x plus 4y equals 4. So if I have x plus 4y equals 4, I would solve for y to see what the graph looks like.
Y equals 1 minus x over 4.
Yes. So I get y equals negative 1/4 x plus 1. So I have my y-intercept of 1, and my slope is negative 1/4. So I'm going to go down 1 over 1, 2, 3, 4. And I get a line. And it's also bounded by x equals 0 and y equals 0. So it should be right in here. Okay, so that's your region. So previously what we were doing is we were rotating it around the x-axis or another line or so on, and we would create these circular cross-sections. So don't draw this because we're not doing that now. But we'd create these circular cross-sections and we'd basically have a cone shape, right? So we're not doing that anymore. So instead we have this region R, we usually call it region R, and we have a shape coming up off the top of it. Okay, and that's what those like manila folder projects in the back of the room look like. So you have different shapes coming up off of the base of a region. Do you guys see those? So off of this, we're going to have semicircles. So we want to know the radius of that semicircle in order to find the area of the cross-section. Okay, so kind of zooming in, here's what we have. So we have a semicircle coming up off of it. I did not draw that very well. So do you see this line right here, which I'm drawing in blue? That's the diameter. How do I represent the diameter?
Is it just 1 minus x over 4?
1 minus what?
X over 4.
Yeah, so it's the negative 1/4 x plus 1, the equation of that line. Right, do you guys see that?
So you just get 9 halves of the radius, right?
Yep, exactly. So we want to find the radius of the semicircle. So our radius is going to be half of that. So I take my negative 1/4 x plus 1 and I divide by 2. Can you see it? So I get negative 1/8 x plus 1/2. That's going to be the radius.
But why is that the diameter is just always going to be the exact same?
It's still doing that same thing we were doing before. We have the top line minus the bottom line to create this distance, right?
So then do we have to find the area of the semicircle?
Yeah, so we're gonna set it up. So our volume is going to be the area integrated, and our area is, they're going to be semicircles, right? So the area of each cross section. So we're going to have pi times r, negative 1/8 x plus 1/2 squared. That's our pi r squared. And then since it's a semicircle, yeah, we divide it all by 2. So you can do it all over 2, or you can pull the 2 out to the front and have 1/2 out front. And then our x values go from a certain x value to x value. So look at the red region that I drew before. Do you guys see how it goes from x equals 0 to x equals 4? So that's what we're going to put in. So we're saying 0 to 4. So we can make it a little bit easier. We can pull out the pi and the over 2. And then I would just use your calculator to integrate quickly. quickly. So instead of foiling out, right, and then integrating by hand, you can actually use your calculator. I just pulled the 2 out, so you don't have to have the over 2 out, like inside of it. So I got that the integral part was 1/3, so I have pi over 2 times 1/3.
2 pi over 6.
Mm-hmm. So pi over 6 is your answer. Does this make sense?
So, will the diameter always be that equation? Like the y?
I mean, it depends on where it is. I mean, you could have cross sections that were, maybe it started at 2 and then you had a triangle. Then that would be, the diameter would be the top line minus the bottom line. Right, just like you're doing with area and volume.
The top line minus 2.
Yeah.
Okay. And then the radius would just be that divided by 2.
All right, so the next one. So it says find the volume of the solid whose base is the region inside the circle. X squared plus y squared equals 9. Do we know what shape that is?
That's a circle.
Circle.
Is, yeah, 3.
Radius of 3, centers at 0, 0. So we can draw that in. You can think of my Professor Steggy. Here we go, here we go, here we go as you draw it. Here we go, here we go, here we go. You don't remember that story? And we're taking cross sections perpendicular to the y-axis now. So previously when we were doing perpendicular to the x-axis, imagine your hand as like a chopping, like a big old knife. We're chopping, chopping, chopping. We're making these cross sections. And when we chop, what's changing as we move our hand from the left to the right is the x value, right? Does that make sense? See how your x value changes as you chop? Now if I'm chopping perpendicular to the y-axis, I'm chopping, 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 and I'm starting at y equals -3 and I'm going up to y equals 3, right? So we're chopping with respect to y. We're making our y's change. So we're going to, when it says perpendicular to the y-axis, we want to integrate with respect to y. So we want to have like the integral sign and a dy. So again, everything's going to be y's, right? Just like before. So we're going to have our limits of integration, our a to b. Those are going to be y's. Our inside part is going to have y's for our function. So it's going to have like x equals equations. And then we're going to have dy at the end. You guys understand that? Okay, so off of this, we have cross sections that are going to be squares. So we have a big square coming up off of it. Or you could have like a little square down here. So there's an infinite number of these squares. Can you guys see the cross sections? I could draw a whole bunch of them, but just like those manila folders in the back. So what I need is the side of a square. So like right here would be one of the sides. Okay, and in order to find that length, right, it's a horizontal distance, we would do our right side minus our left side. Okay, so this equation was x squared plus y squared equals 9. So can we find the right side of that equation and the left side of that equation?
Aren't they just positive and aren't they opposites?
Yeah, so I have x squared plus y squared equals 9. I know I want everything to be in terms of y over here, right?
X is equal to the square root of 9 minus y squared.
Yeah, so I'm going to take the square root of it, and I do plus or minus, right? So on the right side of the curve, this is the equation, x equals positive square root of 9 minus y squared. But on the left side of the curve, do you guys see the difference? That's equal to negative, right? Negative x values. Okay, so we have two separate equations. So then what is the distance between them? If I want to come up with this distance?
2 times 9 minus y squared.
Yeah, and what were you saying, AD?
Yeah,
Yeah, so really, I mean, if you take your right side, that was the 9 minus y squared under a square root. And then you do minus the left side, and our left side is that negative square root of 9 minus y squared. So that's what Ian and AD are saying. They're saying, well, can't you just like double? Do you guys see how this distance is really double this part of the right? They're just saying 2 times. So you can do 2 times the square root of 9 minus y squared. Okay, and that's like our side length of the square. So what is the area of the square then? Well, how do we find the area of a square? Yeah, we take our side and we square it, right? So we just found one of the sides was 2 times the square root of 9 minus y squared, and we're going to square it. So that's what we're integrating. So our volume is going to be 2 times the square root of 9 minus y squared, squared, and then we're going from y value to y value. So what's our smallest y value and what's our biggest y value? Yeah, Ian?
-3 and 3.
Yeah, we go from -3 to 3. Do you guys see it? Okay, so whenever it says perpendicular to the y-axis, we integrate everything with respect to y. Perpendicular to the x-axis, everything with respect to x. And so then we get our answer. This one would be pretty easy to do by hand. You could also use symmetry. Do you guys see how we could use symmetry to help us? Yeah, so we could have 2 on the outside and go 0 to 3. And then when we're squaring this, we end up getting 4 times 9 minus y squared, which would be pretty easy to do by hand. But you can also use your calculator if you want to. I'll cheat. So 9 minus x squared. Oh, I'm not using my normal calculator. Did you guys get it?
You don't have
You're
to find
integrating.
But if you double it, you can just do 0 to 3. So you can go 0 to 3 if you double it. You can see how this distance, or this volume, will be the same as the volume down here.
So this one you only found the diameter, you don't find the radius, right?
Yeah, we didn't need to find a radius because we didn't have semicircles this time, right? We have squares, so we're finding that side. So think about what shape you have. And we could also have triangles. We can have lots of different shapes there.
These problems will tell us.
No, they squared it.
Will it tell us the shape?
Yeah.
Shh, guys, I can't hear. Hey, will it tell us the shape?
Yeah, like these first two said like semicircles.
Yeah, we'll tell you, like the cross-section perpendicular, and that's where those things back there are going to come into play. You guys are going to do a project for the second half of your double here, and we're going to try to make those. Some of you that are artistically challenged are going to have some trouble with this, so I'm going to put you in a group, and someone can help you with scissors and coloring if needed. All right, so let's do this one. So it says find the volume of the solid in which the base of the region bounded by the graphs of f of x equals 1 minus x over 2. Do we know what that looks like? That's a line. The slope is -1/2. The y-intercept is 1. So I'm going to go down 1, right 2. Oops, missed it. And then I have -1, and now my slope is up 1, right 2. So it creates that little region there. And then x equals 0, so we're going to have this little triangular region. Okay, and it's saying that the cross sections perpendicular to the x-axis are squares. So we're perpendicular to the x-axis, which means we're integrating with respect to x. So we're making our chops. We're going like this. And off of those chops, what shape do we have? We have squares coming up off of it. So it's kind of hard to see. But it will basically create those like 2 ridges, like that rectangular example. All right, so we need to figure out what this distance is right here. So this is one of the sides of the square.
You just do top minus bottom. Right?
Top minus bottom, that's it. So our top curve was that f of x, and our bottom was g of x. So you could really just write it like that, f of x minus g of x. So when we integrate it, if it's a square, our area then is going to be our side times side, right? Our side squared. So that's what we're integrating. And a lot of times on the AP test, if you just set it up with your f of x and g of x function, that is totally fine. You get full points for that setup. So that's the easiest way to write it. And our x values go from 0 to what? Do you guys see where they cross? 2. So that's going to be our volume equation. So if you want to write it out after you've written it the simple way, that's fine. You can write 1 minus x squared. See, I almost made a mistake there. I would have missed it for that, putting a plus there. And then minus g of x was -1 plus x over 2, big parenthesis, squared, dx. And then you can find it. Do you have it? Okay, Ian says he has it. What do you got?
A over 3.
8 over 3, did you guys get that? Alright, so that's our volume. Alright, so the first one said that the cross sections perpendicular to the x-axis are squares, but now this next one says, well, what if they're semicircles?
You just multiply that by 1 times 5.
Okay, so let's think about it. So if we have semicircles, okay, you would have this, previously I called that the side. What is it when we have a semicircle coming up off of it?
Diameter.
It's the diameter. So our diameter is going to be that f of x minus g of x.
Cut that in half.
Yeah, so you got to cut it in half first. So our radius is going to be f of x minus g of x over 2. So our volume then is going to be our pi and our r squared. And then all divided by 2. Don't forget the divided by 2. Because some people are like, but I already divided by 2. No, you divided by 2 to get the radius, but remember the area of a semicircle is going to be your
Is
pi
the
r
over-
squared divided by
is
2.
the over 2 within the square? Don't you divide by 2 after you square it?
I haven't done that yet. So take everything and then divide all of it by 2.
Oh wait, why'd you have an over?
Because I was getting the radius, right? So it gets kind of messy in there. I would pull out the pi. Yeah, so pull out pi over what? Pi over 2. You can pull that out. And then you can actually pull out, the bottom will become, if you square it, like if you do your f of x minus g of x quantities squared, which you've already found. That was wasn't that the last answer? That was our pi over 8. But now it's over 4, right? Or pi over 8, did I say? Why did I say pi over 8? I was already doing the problem. 8 over 3 from before. So now we have a pi over 8 out front, and then we have the integral from 0 to 2 of f of x minus g of x squared.
Where did you put in there?
I'm saying like this part. Okay, so if I square this, what do you get? 4. Okay, that's here. And then I pulled it out, and I got pi over 8. You see it? And then I was saying the convenience of doing that is that you don't have to put it in your calculator again, because this part that we have now, the f of x minus g of x quantity squared integrated, that was the answer from the last one. That was the 8 over 3. So you end up getting an answer of pi over 3. So sometimes you can kind of use your answer from before.
So the pi over 8 came from
So you don't have to do it that way, guys. You can put it all in your calculator like that. I don't care. Whichever way you want to do it. I was just making it easier so I didn't have to integrate again. All right, so this next one. So the cross section is perpendicular to the x-axis. So again, we have this triangular shape. We're taking our cross sections perpendicular to the x-axis again. So previously that was side, right, when we did our squares. But now they're going to be equilateral triangles. These ones are always hard to draw, especially if it's a triangular region. So these equilateral triangles coming up off of it. If you know the area of an equilateral triangle, it makes your life so much easier. Do you guys know the formula for an equilateral triangle? You could do 1/2 base times height, but that's not really that easy. Because what's the base? What's the height, right? So the area for an equilateral triangle is the square root of 3 over 4 s squared. That's an S. I use cursive S's because my S's look like 5s. You guys know this from related rates, right? So here's where it comes from. So if you have your equilateral triangle, oops, and you know one of the side lengths, then we use 30, 60, 90 triangles. So if we have S as the side length, do you guys know what goes right down here? Half S, yeah. So 1/2 S. And then with the 30, 60, 90 triangle, whatever is across from your smallest angle is your smallest side. And you take that small side and you double it to get the S, right? And you multiply by root 3 to get the other one. So if I take 1/2 S and I multiply by root 3, 1/2 S times root 3 becomes root 3 over 2 S, right? So then the area of that triangle then is 1/2. The base, this whole base down here would be S, 1/2 S plus another 1/2 S. And then the height is √3 over 2S. So do you guys see how that becomes √3 over 4S squared? I would just know that because equilateral triangles, blah, blah, blah. Okay, so anyway, so we have our area of our equilateral triangle, which is √3 over 4S squared.
S
And
is the same thing
this is
again.
our side, right? So our side is S, which was the top minus the bottom, right? F of x minus g of x. So when we set up our formula, we have our volume equation is equal to the area integrated. Well, our area is square root of 3 over 4 times f of x minus g of x squared, going from 0 to 2. So we get square root of 3 over 4 that we can pull out front. And then notice how, again, you have that f of x minus g of x that we had from part A. And what was that answer? I'm hoping Ian got that answer right now that we've used it multiple times for A. Yeah, it was 8 over 3. Are we sure it was 8 over 3?
Yes.
Okay, just making sure. So we get 2 √3 over 3, right? So that's that answer. Okay, is that it? Are we done with the AP Calculus notes? Is that exciting? Not really, we still have the AP questions in the notes, but good. Awesome, we'll stop there.